this is a rather irregular sum because it uses a rule that is there, of course, that rule is very common, but this type of sum is not usually tested. So I want you to pay special attention to this particular irregular sum and remember this irregular sum. The first thing that you need to remember, area is proportional to the frequency of the histogram. So area is not equal to the frequency, area is proportional. That means the area is equals to some type of a constant times the frequency. So this constant, what we assume, we usually assume this to be 1. So assume k equals to 1, but that doesn't happen all the time. In this particular sum, we have to know the relationship of area and frequency, because if we want to do this sum, the first thing is this is a 5-mark sum. Now they ask for find the number of runner, meaning frequency, between 78.5 to 90.5. So that means this one. Now you know the class width is 90.5 minus 78.5, so that is going to be 98.5 minus 90.5. 90.5 minus 78.5, that is going to be 12. So this class width, very easy to know that this is 12. And if you pay attention here, this is a rather small picture, but if you pay attention here, we know the frequency density, this is 0.5. Then we know this is 2. So we know this is 1.5. This is 1.5. This is 2. Then we know this is 6. We know this is 7. We know this is 5.5. So from here, this is 5.5. So we know all this information. So if you just do the sum, so this area, if you consider this to be, so the height is 0.5, so the area is going to be 12 times 0.5. 12 times 0.5 in one line, the sum is done. So the clue is this is a 5-mark sum. So there is something to do with k. We have to know the relationship in this sum. What is the value of k? Usually we just do the sum assuming k equals to 1. So here we have 140 runners, that means the total frequency. So this is the total frequency. At the same time, we have enough information to find the total area. So if we know that area is equals to k times frequency, and if we know the total area and if we know the total frequency is 140, and then we can find the value of k. That will give us a clear idea of what's going on. So let's do this. So total frequency or total area, so total area is going to be, so total equals to, so this class width is going to be 1 and this is 6, so 6 times 1. Remember, frequency density equals to frequency divided by class width. So the frequency can be found by multiplying the frequency with the class width. That's what we're doing. The next building is, everything of this is 1 unit, because this is 60 to 62.5. This is 2 units, so this is 1 unit. So this is 1 times 7. So 7 is the frequency density times 1. So the next building is 1 unit, 2 unit, so 3 unit, and 1 unit, 4 units. So 4 times, this is 2, so 4. So 2 is the frequency density times 4 plus, so this one done, this one done, this one done. This one is 2 unit and the frequency density is 6. 6 times 2 plus this one done. This is 5.5 and this is 2 and 1, 3. So this is 3 unit times 5.5. So 5.5 times 3 plus this is 2, 2, 4, 5 unit. 5 unit times 2. So 2 times 5 plus this is 2 and 1 3 unit, this is, remember, this is 2 and this is 1 3 unit, and this is 1.5, so 1.5 times 3 plus this is 2 4 6 8 10 12 unit, so 12 unit, and this is 0.5, so this is 0.5 times 12. So let's calculate this. I hope there's no mistake because I've done this rather quickly. So 6 times 1 is 6 plus 7 1 is 7 plus 2 4 is 8 plus 6 2 is 12 plus 5.5 times 3, okay, plus 5 2 is 10 plus 1.5 into 3, 1.5 times 3 plus 0.5 is half, 6, so this is 6, so 70. So we found that the total area is 70, therefore total area 70 equals to constant time total frequency is 140 runners, so 140. So therefore the K is 70 divided by 140 equals to half. So the area is actually half of the frequency. So now if you find the area here, that makes it, hence, so for this one, for 78.5 to 90.5, we can find that the area is 12 times 0.5 because class width is 12 and frequency density is 0.5, that is the area. So 12 times 0.5, so equals to K is half times frequency. So we need to find the frequency. So therefore the frequency is going to be 12 times 0.5 times 2 equals to F. Therefore F equals to 12, because 2 into 0.5 is 1, 1 into 12 is 12, so there are going to be 12 runners. So this is a sum for which the value of K is not equals to 1.